Okay, we'll get started. Thanks everyone for attending my session. Today I'm going to share with you about Baidu's cloud blockchain project's result, Hyperledger Fabric Operator. Want to build a faster and simpler blockchain consortium management tool? Okay, let me introduce myself first. Right now, I'm architect of blockchain cloud of Baidu. I joined Baidu in 2014. I've been worked in PaaS and other architecture work. Today, I'm sharing with you about Fabric Operator. So it is related with Fabric. So I need to give you some background about what is Fabric, what is Operator, and ultimately it will be talking about achieving Fabric Operator through our design, and then we can also see the design and implementation of Fabric Operator. First, let's see what is Hyperledger Fabric project. I think Fabric is the most popular blockchain architecture. It's also the #1 permission blockchain. So this is a subproject of Hyperledger, and Baidu is also a senior member of that. And also, we are looking at Fabric, what can it bring to us. So I've listed several things. So it has the features of organization, abstraction, modularized structure, grouping of ledgers, pluggable consensus. So we can see the consortium blockchain is based on organization, so you always need to join as an organization. And within the organization, it's also modularized components. For example, we have the CA components, which is doing the distribution of the credentials. And we also have a peer component, which is to maintain ledger and maintain the transaction rules. Another one is about audit module, which is providing overall sequencing services. And the third one is about the channel. So the channel is actually providing the consortium blockchain with multiple ledger sharing. So between different chains, they are separated through channels. The last feature I summarize here about the orderer is that it can be replaced real time because orderer is providing independent services. That's why it's pluggable. Now we also have PDFC, Rust, etc. And major thing is based on Kafka and others. So there are two abstract concepts that I need to explain here. First of all, about the Fabric Consortium blockchain is providing an identity services, which is called MMSP. What it can do is to define what kind of identities within the organization and how do these identities connected with each other. So it uses a digital credential and PKI's credentials. So we can see MSP is a set of credentials. Another concept is about channel, which is not a specific module. It's an abstract concept. Actually, for its implementation, you need to have a group of MSP. So for one channel, the MSSP will link to all the MSSP credentials within the organization. And for these credentials, there will be different organizations who will host that. So this is about the operating structure. After we see the operating structure, let's see how is Fabric deployed. So I have divided that into 3 steps. The first one, you need to build organizational consortium. First, you'll need to establish the CA, and then these organizations can be linked into a system channel. For the second step, you need to build ledger channel, because when you build the organization channel, so the ledgers cannot be shared between different channels. So you need to have a ledger channel, which will be established by the organization admin. And when you build the channel, you still cannot have a transaction or blockchain, because the format of the ledger and transaction is not defined yet. So that's why you need to have the DMP deployment. After you do these things, the Fabric consortium will be completed. So it seems to be very simple, but actually there are a lot of operations included. I have listed 2 scenarios operation process here. So this is the flowchart, which is describing organization A and organization B wants to join a consortium. First, each organization needs to build their CA node and then generate their credential system. And Order is an independent organization. It also has its admin, which collects MSP credentials of different organizations, and it will create an orderer configuration, and the orderer generates a block, and then organization A and organization B will also generate the peer nodes, and when these nodes are initiated, this consortium will be established. Actually, is linking the MSP of organization A and organization B. And then second step is building a ledger channel. Both organizations also needs to provide their MSP and their description document, and then the peer will issue a transaction, and then the channel will be generated, and organization A and organization B can proactively get the genesis block and create their anchor peer. Now let's look at another scenario, because consortium will not always remain unchanged. There will be some new organizations joining this consortium. So for a new organization also needs to build their CA node and then generate a credential system, and then they will generate the basic configuration of the organization, and then they will need to update the system channel, and organization A and organization B are both in the channel, and then you can generate the larger channel. Order is also taking organization C's credential document and create an updated transaction, which needs to be signed by admin of org A and org B, and then sent to orderer to create this transaction. And then in that, it will include the configuration of org C. And then org C will be able to start with the transaction. Actually, when we are creating Fabric manually, there will be a lot of things, including the command lines, operation, etc. Actually, we also have several sessions focusing on this area. How do we reduce the complexity of this operation? So I'm listing the official solutions provided. The first one is a binary deployment proposals, but this one is targeting for the developers. If it is me deploying Fabric, normally we will need to use Docker Compose, which is a method described by the official tutorial. I need to do that step by step according to the instructions. But there were 2 problems. First of all, Docker Compose is a single machine application tool. If it's a distributed system, I need to log on each machine for that operation. And also, Docker Compose cannot include all the steps. Most of the steps still needs to utilize the command lines or interfaces of Fabric. And the third solution is using Cello, which is an orchestration engine specifically for Hyperledger, like Fabric or other blockchain projects orchestration method. For us, it's a brand new platform. At least for me, it's too heavyweight. So what we need to do is to understand about our needs. Baidu Cloud wants to launch a blockchain platform. Its goal is to manage the blockchain.
So there are two requirements. One is how to run a Fabric Consortium blockchain in a sustainable way. And the second is how to open the necessary configuration for the administrators of the consortium blockchain to do the necessary deployment. So for the first requirement, to use Kubernetes to deploy Fabric is a good way, but we think that only by using Kubernetes to deploy Fabric is not enough, because while we are deploying Fabric, Kubernetes can help to start the container, but also we need to rely on some other ways. So what we want to do is to provide a consistent control so as to deploy the consortium chain. So that is why we think that the operator can help this. So what is the operator? To put it simple, it is a kind of tools. So what benefits it can bring to the customers? So via KubeCon, it can manage the self-defined resources, and also it can have access to look at the KubeCon status and the Kubernetes. The different functions can be realized, like the CRUD watch. And the third benefit is very cool. For operator, it can help users to monitor the resources and to correct the gaps between the current status and the expected status. So if you have a Fabric operator, what can we benefit from? First, it is for the cluster administrators. If they have the Fabric operators, they can check for what resources which organization or which Fabric organization it belongs to. And also, via the Fabric operator, it can judge the status of the Fabric organization. And the second benefit is for the consortium administrators. That means via the command lines, they can realize the configurations of the organization via KubeCon. And the third one is that we have integrated the Fabric identity and authority to the K8S system. So for the Kubernetes operator, how it can be realized? Operator. There are some questions, but the speaker is not using microphone. Please use the microphone. You are talking about the certificate of peer and order to be managed by the Kubernetes. It is the certificate of the administrators. The certificate will control the Fabric operator. Later, I will talk about that. So for the Kube operator, there are two steps. One is the CRD, self-defined resources. You can define it, and then it is a kind of static structure to store the data, but it cannot meet users' requirement to use the resources. For example, if I want to build a fabric resources, needs to have controller to realize. Controller have two tasks. The first one is to define the following moves of API, and the second is to satisfy the kind of coordinator mode. It needs to watch Kubernetes API to observe the gaps between the current status and the expected status so as to try to make the two status the same. So how to realize this operator? Here we are. So the core is based on the event. We are going to invoke some of the logics. So you can see that there is an informer. The informer will feed back the event to the handle resource and reflector, and then it will filter some events to put it into the work queue, and then the worker will process the event. Sync handler, after getting the events, they will first get the object of the event, and then they will analyze the current status and the target status so as to work out the gap between the two status. And at this time, it will use the Kubernetes API, so that is a closed-loop process. So how the fabric operators has been realized? First, it is a definition of the CRD. The CRD, it is a self-defined resource. So while we are thinking about splitting the resources, the starting point is what resources the administrator is to manage. And we found that during the real implementation, there will be an organization which will initiate the establishment of a consortium, and then this organizer will have different followers. So the organizer will become the orderer. So we can say that for organizers and followers, they are different in terms of their architecture. So we'll define two CRD for the organization which is establishing the consortium. We call it organizer, and then followers and channel. It is a kind of virtual resource. So the difference is for fabric channel, there is one, but this channel belongs to some organization. So that means for fabric channel, there is only one, but for CRD, there are two channel objects which is belonging to different organizations. So how the CRD resource belongs or match to different resources of the Kubernetes. So we can say that for organizer has the namespace, and then we will deploy the peer and then orderer. So all those modules are started via Docker. So we can say that for the dotted line, it is about the network communication, while for the solid line, it is kind of like volume relations. Because as I have mentioned, this is kind of certificate system. The certificate will be distributed to the different modules. So we are using this kind of mechanism to realize that while connecting to Baidu Cloud, it is via the BOS. So another thing is job. What does job do? Job will invoke some of the interface, because controllers cannot directly invoke the Fabric API. That is why we need to rely on job to do it. And another one is for follower, we can say that there is a leader peer. It will invoke the orderers across the different namespaces. So next, let's talk about the question which has been raised. So for the authority correlation, we first let's see how to have the builder only have the operator resources. That is how to limit the users to invoke Fabric operators. So can say that we can define some model, and also we can define that only the members of the organizations can have the authority to manage the Fabric. Because we are using some certificate which can match the MSP certificate of the organization. And the third one is for the KubeCon organization cluster, how it can manage different resources. It is under different namespaces. So for this one, let's start with the cluster administrator. It is to define two different kind of things. One is the role. The role is like an organization administrator, and the second is bundling of the role, that is the user. So the definition of the role are related to three factors. One is the API groups. So we have it as cloud.baidu.com. And the second factor is what resources we are going to consume. That is the CRD resources like organizer, followers, and channels. And the third is what we are going to do against the resources like the CRUD, the watch, the data. And then the second is to break through the IDs or the certificates. For Kubernetes, you can say that they recognize the certificate. So that means you need to put it in the sequence and then to correspond to the Fabric, because Fabric has the similar certificate. So the two have the same identity for the different organizations. So that means once a user has got the admin certificate and then will request the KPS server, and then they found that this certificate is valid, and they will say that this ID can meet the requirement of this role, and then they can use or can choose the different resources. And then next is about the process. So first, it is a kind of like initial status. First, users will submit some files, and then controllers will build the namespace, the storage, and initiate say and order run. And then after starting run, it will build some initial forward resources which are related to the system channels, and then it will start till and then mark the organizer as running status. So actually, to mark it as running, that means some of the stacks cannot be modified. For example, the name of the organizers cannot be changed, but the peers or the orderers can still be changed or modified. If there is any abnormalities, controller will feed back to the work sequence, or if it is too many times failures, then it will mark it as error. And the second typical process is to establish a new channel. So first, we need to define the configuration of the channel target, and then we will add follower A in the channel, and then follower B, if it also wants to join the channel, then the administrator needs to apply a request, and then to establish the related channel resources, but it needs to follow the signature of follower A, and then it needs to submit the organization description, and then follower B will provide this to the administrator of follower A, and then after adding the organizations, they will do the signature.
After the signature, you would find the channel has been established, and then you will be able to deploy the MSP. So these are the configuration of both objectives. Actually, it's very similar to the native resources. So we need to configure as app organizer, and then we can name it, the number of the nodes, and also configuration of bus, which is used for mounting or PV. And in the right side is the channel definition, and you need to link to text off, and then you need to set the level, and the other thing will be in the spec. And for these organizations, a list is here. And let's look at the static process of controller. So I highlighted two major things. One is organizer, the other is channel controller. So for organizer, it will define related events, and then when it is establishing an organization, it will also create jobs and deployment, and those things will also be subscribed, and it will also generate some events. Actually, it's calling API to create a default channel, and for the event of the default channel will be captured by the channel controller, and then it will subscribe the channel's resource events, and the other things will be jobs events. So it is monitoring these two types of events. These are the implementation of controllers. Next, I'm going to talk about the design rules. Fully utilize native resources. So we let CRD create some natural rules. And the list of resources needs to comply with the KISS rules, because it needs to be very clear and intuitive to the users. And then about the processing logic, we need to have a very detailed and specific rules so that users can know. And we also need to use more linked resources. We can create a job, create a deployment, so that we can have some async processing. And through the secondary resource events, we can monitor these events, which can be put in the back end. And then the controller needs to be outside. While we're developing, of course, we need to do some debugging. Of course, you will not push that to the mirror always. So that's all for my sharing today. Do you have any questions? Please wait for the microphone. First of all, I want to know, for your operator, it's only in K8s? Yes. In the production environment, maybe there will be multiple organizations building a consortium blockchain. Different companies have their KBS clusters. You won't be able to use that. Actually, you can use it, because one organization can be using K8s, But when you have between different consortiums, you will be able to call that. And you can also put that on the public cloud. Another question, you didn't mention about the link code installation, because according to the native fabric, you cannot use that. Do you have a WAM controller expansion? That is in our plan. I didn't mention that because we haven't done that yet. We have done the first 2 steps of the 3 steps. That's all for my question. Thank you. Hello? I have a question. So will operator have a deep understanding of the configuration information? For example, if you're converting from 3 channels to 4 channels, so the majority of the channels will need to agree. That's why you need to collect 2/3 of the signatures. So for the operator process, would you be able to understand that when any 2 organizations have completed the signature, then you can submit the order to, or you have other ways to process that? We will create a job which will be responsible about the signature logic. It will have a statistic of how many signatures we have collected. According to the majority policy, if that requirement is met, then it will submit that. We will have a cycle there. Thank you. Any other questions? For the controller and the codes you are creating, do you want to make it open source? Yes, we're going to make it open source. We're still doing the adjustment internally because we're also doing some channel developer. My name is Li Tong. I'm Chalo's committer. I hope that we can support operator. What we're doing is using another method, but we hope operator can be added. Okay. I also want to do some advertisement here about what you have mentioned about different organizations. How do you build a consortium blockchain? There will be 2 sessions tomorrow. One session will be talking about that, which will take place at 9 a.m. Okay. I want to talk about the authorization linkage. Because you have org1. So you need to have a KLS. Doesn't mean that every signature needs to have that engagement. Every time when you have a new member, you will have a subject linkage. There will be a list where the new member will be added to that. For org1 admin is okay. So you don't need to have a cluster admin. Of course, you can also have that. The cluster admin can assign that to org1 admin. Okay, that's all for my part. If you have any questions, we can have an offline discussion. Thank you.